All right, next speaker is me. Hey, everybody. Let me do some screen share. This is really short. Will easily fit into our little window here. Here we go. So this is a project that's spun out of a question, and it almost always is for me, where someone says, hey, can we do X? And X in this case was, we have storage accounts, we have Key Vault, and they all do in Azure IP permit lists. So they are specifically permitting certain IPs down here on networking. I should have had this pulled up, but here we go. So here are the firewall IPs that are permitted, and here's the virtual networks that are permitted to talk to this storage account. That's really useful. That's a really wonderful security feature to enable for storage accounts and for Key Vault, so that they can only be accessed from where they should be accessed. So even if someone has maybe an authentication key or a password or something like that that should grant them access, if they're coming from the wrong place, say overseas or outside the company, they can't get in. So that's a wonderful thing to turn on. But it's pretty hard to turn it on given Terraform's limitations. So say we want to, this is exactly the request we got. We have several different subscriptions, and we want to identify all of the subnets in all of the VNets in all of the resource groups and filter them based on the specific, names that should be deployed. And keep in mind, this is the Chia project, so we'll have hundreds or thousands of copies of these different accounts. So it could potentially be thousands of subnets that we would need to permit. That's a lot, right? That's a lot of subnets. Here's all the VNets that exist today across the Chia subscription. That's tiny, but that's okay. You don't have to read it. I just want to implore you, this is so many. So these are all VNets, which contain subnets. So this one is actually 4. This one is actually 7. And we want to find all of them and aggregate them with Terraform. So let's check that out. The Azure RM provider, if you've worked with Azure, this is probably the provider that you have used, does have a data source for subnets. That's awesome. Okay, problem solved. But not really, because it can only find one. And it can only find it if you know specifically the name and the VNet name and the resource group name. So you have to somehow construct all of that information to find a single subnet. And we might not always know that. And even if we do, say we have just perfect logic to find all of the resource groups and all of the VNets within them and all of the subnets within them, if any account is slightly different, it's going to fail because it's going to try to find it, and Terraform will puke and say, no, I can't do that. Or what if we create a new subnet type? We'll have to update the logic. Or what if we create a new pod deployment, which is going to happen all the time? Remember, there's hundreds of pods or maybe thousands in the future. Do we need to go to that storage account Terraform config and update it so it knows about the new one in order to secure it and permit it? All of those options sound like relatively terrible. So the reason I bring this up, the reason I'm talking today, is I solved it in kind of a hopefully creative way. I think kind of cool. I used a different provider called let's just bring it up, AzAPI provider. Totally not found. This is a live demo, so we'll see how this goes. The AzAPI provider is an alternative provider for Azure. And you can see over in the Azure RM provider, there's tons of resources. There are tons of, there's literally thousands of resources and data providers. In the AzAPI, there's 4 and 4 lookups. So you can find a specific resource or you can find a list. And a list is what we're going to use today. So it's not terribly intuitive to use. The AzAPI literally talks to Azure's API and gets this huge JSON response. But how do you know how to use it? How do you know what the response is going to be? So let's go do it. This is an example. I'll share a link, and it's also in our Veradigm Tech Live page for this month, which is in the chat bar here, for how to use this. So first of all, this is the finding all the subnets one. This is the providers. So first of all, this will look really familiar. We have the Azure RM provider. This part is exactly the same for most of our Azure deployments. You might have a different version, but you still use Azure RM, but you probably don't use the Azure API. That's the thing that we used. You can see it's a different version, it's a different name, it's literally a different provider binary. And this one in particular, you don't have to call out the different accounts, but that's what I want to do. I want to look up stuff in dev, stage, and prod. So I just store those as local values. That's totally within Terraform. And then I register providers. We'll just go over one. This is the dev provider registration for Azure API. And this is the dev provider registration for Azure RM. It's totally fine that those are pointed at the same subscription because they're different providers. So even though they're connecting, they're like hooking up tubes to the same subscription, that's fine. They're different providers, so they don't conflict with each other. Now that the providers exist, we can start to do lookups. The first one we're going to look up is find all of the resource groups. Like, let's just find all of them. So the way this looks is you specify a provider, which again just means subscription. We registered it to look at dev, and we want to find all the resource groups. And again, this is an API version. You kind of have to Google around for these. I haven't found a single source of truth, but if Sai is on this call, I'm sure he knows them all by heart. So you could probably just ask. And we're saying, look in this subscription, dev, and find all the resource groups and print them out. But like, what does that mean? What's it going to look like, you know? So here's Terraform in the exact same place, and we're going to do the Terraform console. You have probably never used the Terraform console before, but it's a wonderful way to mess around with like Terraform logic or see what these are going to output. Like, let's go see, what's it respond with? Well, it says, I have no idea because it hasn't run yet. So what we're going to do is run a Terraform apply. I have authenticated, so live demo gods, let's see how it works. It apparently succeeded. You can see all of these start with data. So it didn't build any resources. It's not updating anything. It's just finding something. We could still use this information to feed into like a storage account policy or something. But in this lab that I built, it does nothing. So let's go in the Terraform console again and run the same thing. So that's data, Azure API resource list, dev pods. That's probably small, but let's zoom in. So here's the ID for the resource groups, and then here's the output. And like, that's awful. That's a really terrible response. But you can see we're getting a ton of information. So like, how do we filter it? And that's the reason we're doing this in the portal. So let's look at the output, and still like pretty terrible. So we can JSON decode it, which is a tofu or Terraform expression as it's an E word that I forget. And we have decoded it. We've decoded that very long JSON escaped string into like human readable JSON. So here's a resource group. There's its name. Here's another resource group. There's its name. And so we can filter through all of these to be able to find them. So like, let's look at value. And now we can look at, I think it's with the little star, which means read through each of them to form a list. And then we can say like, hey, we actually, we want all the names. And let me check to make sure I'm right. I think I'm in the wrong place. I think it should be there. There we go. So in the dev account, that's all of the resource groups. And that logic, like JSON decode, output value, star name, you would never figure that out yourself if you're just guessing. So the Terraform console is just incredibly useful here. And you can also filter it. So I just have some local constructs down here where we're doing filtering, and I'll just kind of copy these and we can see what they look like. But basically we're doing an iteration through. So let's scroll this over a little. So for a route group in, and then this is the exact same thing that I just typed. So like read through the list and filter through them, do a regex. So if you can regex this P, DDD, and there's all these backslashes, and this is just simple regex syntax to say P, digit, 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 .net, print the route group. So basically it's just filtering. So let's copy it and see what it looks like. So apparently there's just two. So of all those resource groups, I'm using regex to filter them. There's just two. Cool. and we store it in locals, and then we do some lookups. This is still AzAPI. It's going to look a ton like what we just saw, so we're still looking in dev. This time, though, we're looking in VNets, subnets, at this API version. And you can see we're constructing the parent ID using this like subscription ID and the resource thing. And you can see the resource group name is each.value. Where does that come from? Well, we're iterating. So we're doing a for each. So for every resource group that exists, loop over it and try to find all the subnets that are within it, which is pretty cool. So let's check it out. This is very much a live demo compared with a very polished thing from Ali. Cool. So again, this is a lot. You can see it's a map of maps. So it's a complicated data structure, and we can filter it based on particular names. So like if we just want to go look at one of them like this, we can. It's still super complicated as a data structure. So it still has that output that we have to use JSON decode on in order to find the list of subnets, but we're able to find all the information, which is pretty cool. So here, if we do for route group and values, set it equal to, so we're sort of starting to process this list. We do local dot blah, 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 and you can see this list now has 0 at the start, but it's combining all the resource groups from dev and all their subnets within it, which is super cool. So now we want to combine them. So we have dev and stage and prod, and this is all the subnets in this super complicated data structure, and we want to find them. So we're going to iterate through each of these to make a list. Oh, it doesn't like my multi-line stuff. Let's make it one line then. So it looks like that. So this is just these subnets that exist in dev within the correct resource groups, regardless of their VNet. So we're sort of reading through all the VNets and finding the subnets. And this is super complicated, right? But for anyone that's going to use this, they can just look at this locals value, subnet names, because it's finding all of them. It's JSON decoding. It's finding their names. And I can look at subnet names like that. And there we go. We found all the subnet names across the entire dev account. And I think I can do length to get the count of them. There's apparently 56 subnets that I need to add to the permit list here. So if I need to add like a permit list for the storage accounts, I can reference local.subnet names and we're done. There's no other logic that storage account would have to do. And notably, there's no config changes that it will ever have to make again. As long as these VNets exist and it can find all of the subscriptions, like it has access to them, the Terraform config, then it's going to find the subnets immediately on next run. So say we deploy 5 more pods. In this Terraform config, we just have to run it. You make no changes, there's no PR. We could even automate the run so it would run every day and find the new ones and permit them. Or just hit the button to go. And it finds them using the Azure API, and it adds them to the storage account list, and we're done. I have a similar thing with VMs. I don't think we'll have time for that today, but we find all of the resource groups. We look inside them to find all of the RAS servers, just filtering based on their names. They all contain RAS gateway. It'll look really similar to what we just did. And if there are any that exist, we can use the Azure RM side of the house to do a data call on a single virtual machine, because we're iterating through all the ones we found in all the resource groups we found. And we can output their private IPs, because we need their private IPs to be behind an application gateway. So even if Terraform's Azure RM provider doesn't give you the stuff that you need, it's very intuitive to use, but it's not as flexible as this. You can use this AzAPI provider to do some really neat tricks and find the stuff that you need when you're working over in Azure. And it can find just about anything. Eventually, I will potentially write some more Terraform stuff so the Azure RM provider could do stuff like this, because like working with JSON, it's pretty complicated and enough that I want to give a talk and tell people this exists in case you want to mess with it. It would be easier if the Azure RM provider just like natively supported this, so we didn't have to be smart. It just worked. But that's where we are. Cool. We have about 5 more minutes. If anyone has any questions, please go for it. I'll check the chat.
This is a very good scenario for when you have a chicken and egg kind of situation where you're building networks and network appliances, but you haven't built the back-end servers yet, right?
Totally. The config pattern here is we have a network layer that we deploy first before we deploy the server layer. They're different repos. And so the network layer deploys the VNets and the subnets and the application gateway. And some of its logic says, go find all the RAS servers and put them behind the app gateway. But there aren't any because that's the server layer. So we would have to deploy the network layer and then the server layer and then the network layer. And I think it even failed because there weren't any RAS servers there yet. So Terraform can have some interesting and terrible dependencies between layers. So this is one way to avoid the chicken and egg problem that Russ was talking about. Thank goodness. And also just the ongoing maintenance problem of if you're hard coding anything, even if it's just a list of pods to look at, we have n number of pods and that number is going to change all the time. And it's not even just in series. We might have 1, 2, 7, 9 because we had to take a couple down to work on them. How many places do you have to make that change? Like potentially a lot. So let's just automate it and then kick our feet up and have a margarita. That's my preferred way to work. Oh, Alex says Terraform JSON. Oh yeah, go ahead, Alex. I was just going to read your comment.
Yeah, I put that in chat because you said expression like a question, so I figured I would just put that note in there. But I was wondering, like when you talk about these dependencies between different Terraform configs, did you have a time when you were trying to output like this list of subnets like an output and then do a remote state lookup? Because I know when you're scaling like this, it can be kind of hard to get your outputs crafted correctly to be able to even share that, that information between remote state.
Totally. Yeah, that's what we did initially for the RAS gateways. It was make it an output in the Terraform state from the RAS servers layer. And that works great as long as the RAS servers layer has been run. So when we initially built this, you sort of build the VNet and then you build some servers and then you build the application gateway and it worked great. But then on a new deploy, you deploy the entire package for network, including the app gateway. And it says, hey, I'm trying to find that remote state for the RAS servers and it doesn't exist for like stage and prod because all we've built so far is dev. And of course it doesn't exist. There is no remote state for those servers yet. So what do we do? Like Terraform, you don't have a lot of the ability to say like, if this provider registration, which is what it's doing to find a remote state, fails, just ignore it and skip along happily. Right. No, it's going to puke and fail. And I wish that there was an option to say like, just ignore this. That's fine. I don't care if that fails. So this is a way to just be tricky and hack around that limitation. And I would love to fix that. I wrote, this feels very braggy because I'm very proud of it. One of the data sources that I wrote for Azure was to find multiple IP groups. And if there are none, it just gives you an empty set, which should be the default for Terraform. And maybe I will make a case on the Tofu side to just say like, please do that. If it can't find anything, just do an empty set because then it can, work through failures instead of just puking.
Well, and it's also.
Yeah, this also.
Go ahead, Alex.
Go ahead. I'll just complete my thought. So part of this scenario that you gave, Kyler, is interesting because you're gathering resources from different environments. This is definitely the exception rather than the rule. So that's my last thought. Thanks.
Totally. It's one of those problems you get when like, if this was all just one Terraform state, that would be a terrible idea, probably. But it would work. It would work fine. But when you start to segment your Terraform, which is a best practice and something you should do, you start to run into problems. So definitely a double-edged sword. You need to do it, but it also is complicated and sucks sometimes.
Well, and it's interesting because in a lot of circumstances, when we build something new, we typically like to just go ahead and deploy it quickly by hand in an environment and then convert that into code in order to actually deploy the code and then have a repeatable process, right? Very common to do testing that way. So if you're taking that approach, you're taking that mindset of I built this thing, then I built that thing, then I built that thing in order to now build this thing, right? And translating that into Terraform doesn't always work, like you're saying. And we even found this out with like VPN gateways in Azure, where if you're trying to do natting, it's expecting you to build the NAT rule ahead of time and attach it to the VPN gateway, because that's the way you would do it logically in the actual config of the VPN gateway. But then the problem is the Terraform code wants you to have the connection already built and established in order to attach that NAT to the connection itself. And that doesn't actually work. That was a problem we found out with Terraform and VPN gateway specifically. But it's kind of, again, that chicken and the egg scenario like you're describing, right? Logically, you're building things in a particular way in order to make them work, but Terraform doesn't always expect it in that particular way.
Absolutely. We went back because this is like you slowly incrementally develop your product. And then we went back and we were like, oh, we need a whole new subscription, like a totally new subscription, all layers new. And we realized all of these layers, A depends on B and B depends on A, and it's a dozen times. And how do you deconflict that? It was a significant problem. And we did, but it took a ton of work and a long process. Run A with a couple variables set to only do a limited deployment, then run B, then go back to A and turn those variables on so that they connect to B. And it's just like, man, it sucks sometimes. I wish it was more failure tolerant and failure responsive. Terraform's not built like that intentionally, but I wish it was.